Welcome to The Explainer. Today we are exploring a massive shift happening right now in academia. We're standing squarely in the middle of the AI research revolution. The tools we have available today can literally turn months of grueling, tedious work into mere hours. But, with that immense utility comes the very real danger of stepping on some serious ethical landmines. So today we're breaking down exactly how to modernize your research with AI while totally avoiding the pitfalls that could derail your academic career.
Look, if your current workflow involves going on Google Scholar, manually downloading 100 PDFs, and reading them one by one just to find a research gap, you are stuck in a decade-old strategy. Seriously. A proper literature review used to take 6 overwhelming months. But in the AI era, the modern approach is all about achieving greater clarity and precision with zero overwhelm in a fraction of the time.
Here's our roadmap for today's explainer. 1. The modern AI research era. 2. AI and the research lifecycle. 3. Academic integrity and AI rules. 4. The AI intellectual property problem. 5. Defining acceptable AI assistance. And 6. Best practices for transparency.
Let's jump right into part 1, the modern AI research era.
The biggest shift here is moving away from basic keyword matching. Let's actually walk through a step-by-step demo on using an AI search engine like Consensus for a literature review. You want to start with a clear research question to give the AI context, not just a string of keywords. Next, fire up the Pro Search and apply some strict filters. Restrict your results to the past 10 years and set the journal rank to Q1 and Q2. That ensures you're only looking at high-quality, relevant sources. From there, you can interpret the consensus meter to instantly gauge the overarching scientific consensus on your topic. Next, shortlist your papers using tags like highly cited and directly access the open access PDFs. You can even chat directly with those PDFs to ask highly specific methodology questions. Finally, push those sources via the Consensus library and Zotero integration to create comparison tables and spot research gaps. It's amazing. You go from mindless searching to strategic discovery.
Moving right along to part 2, AI in the research lifecycle.
Take a look at these 9 distinct stages of the research cycle. From problem identification all the way down to peer review, AI acts as a powerful enabler at every single step. It helps with semantic search, data cleaning, statistical analysis, the whole shebang. But notice the very center of this ecosystem. It's the human researcher. That's you. You are the one who leads, decides, validates, and takes responsibility. AI accelerates the mechanics, for sure, but your critical thinking absolutely has to remain the ultimate decision maker.
So, if you're a PhD scholar preparing a literature review or a survey paper, here is a highly practical 3-step synthesis workflow you should adopt today. Step 1. Search for your core papers using Semantic Scholar to completely bypass keyword limitations. Step 2. Import those papers into ResearchRabbit to visually map citation networks and discover related work you might have missed. Step 3. Upload those PDFs into NotebookLM. You can ask it to compare methodologies across papers, identify common limitations, and highlight research gaps. It is an absolute game changer.
All right, part 3, academic integrity and AI rules.
Okay, so the stakes here are incredibly high. Just look at the stark reality of the revised guidelines from the University Grants Commission. Unacknowledged AI-generated content is now treated exactly like plagiarism. If an AI similarity check flags 10 to 40% of your thesis, it gets returned for a 6-month revision. What if it's 40 to 60%? You are barred from submitting for a full year. And if you exceed 60%, your entire PhD registration may literally be canceled. The core content absolutely must be yours.
Which brings us to part 4, the AI intellectual property problem.
The global legal consensus right now is perfectly captured by the fascinating Davis patent case. So, an AI system named Davis autonomously invented a fractal beverage container and a warning beacon. The AI's creator filed patents globally, naming the AI as the sole inventor. And the result? It was rejected almost everywhere. The US, UK, Europe, Germany. Why? Because under current patent law, an inventor must be a natural human person. Human inventorship remains legally essential on a global scale.
The reason AI cannot be an inventor or an author really boils down to this core principle. Authorship isn't just about producing content. It is the acceptance of absolute liability for the accuracy and integrity of that content. AI inherently fails the authorship test because, well, there's no legal entity to sue, retract from, or penalize if the AI causes harm, hallucinates fake facts, or plagiarizes someone else's work. The accountability chain completely breaks without a human.
Now for part 5, defining acceptable AI assistance. Given those severe stakes, a really great mental model is to think of AI as an assistant, not an oracle. Acceptable use means you're using AI to write Python scripts for data cleaning, brainstorm angles, or just improve the fluency of a draft you already wrote. Unacceptable use, which is treating it like an oracle, means asking the AI to autonomously generate a novel hypothesis, draw conclusions from complex results without your oversight, or just blindly copying AI-generated paragraphs.
This distinction is especially critical in new paradigms like vibe coding, where researchers use natural language to generate code and data visualizations. The boundaries here are super clear. Do use AI to assist your coding, but you have to validate all generated outputs. Do document the assistance, but never ever submit code you don't actually understand, and never use AI to generate experimental results. True intellectual ownership means you can defend every single solution the AI helped you build.
And finally, Part 6, Best Practices for Transparency.
Major publishers like Springer, Elsevier, and Taylor & Francis, they now explicitly require targeted disclosure of your AI tool usage. You need to use exact, acceptable templates to comply. You can be comprehensive, stating you use ChatGPT to improve clarity and flow and verified all suggestions. Or you can be tool-specific, acknowledging you used Microsoft Copilot to summarize field notes. The key here is unequivocally stating that no core scientific conclusions were generated by the AI. You did the science. Now, if you are leading larger-scale research projects, you really should be familiar with the UNESCO framework tool called the Ethical Impact Assessment, or EIA. Before you deploy an AI system, say a tool to evaluate student assignments, an EIA forces you to systematically anticipate risks. Will the dataset show bias against non-native speakers? Are there privacy concerns? You must identify and mitigate these ethical risks before your systems ever affect real people out in society.
To bring this all together, here is an actionable checklist every single researcher should run through before submitting a manuscript or deploying a project. Ask yourself, is my dataset unbiased? Was informed consent obtained? Are my results actually reproducible? Have I disclosed my use of AI tools? Can I use explainable AI techniques to prove why my model made a specific prediction? And are privacy risks mitigated? If you can confidently answer yes to these, you're doing research the right way. I want to leave you with this final thought. AI is arguably the most powerful accelerant the academic world has seen in decades. It's going to speed up your literature reviews, your coding, your data processing. But at the end of the day, speed is completely meaningless without integrity. AI can accelerate your discovery, but how will you ensure your research remains trustworthy, human-centric, and ultimately benefits humanity? Thanks so much for joining us for this explainer, and we'll catch you next time.